Welcome learners. In our lesson today we are going to look at carbon and its compounds. Our subtopic is carbon-2 oxide. We begin by looking at laboratory preparation of carbon-2 oxide. Now carbon-2 oxide can be prepared by two ways: dehydration of methanoic acid or oxalic acid, 2. Reduction of carbon-4 oxide using coke, that is carbon. So the first method, which is dehydration of ethanoic or methanoic acid, the reagents used here is concentrated sulfuric acid, which act as a dehydrating agent. So first we begin by looking at what is dehydration first. Dehydration is a process of removing elements of water or water molecules from a compound. Dehydrating agent is a substance which is capable of removing elements of water or water molecules from a compound. So A, dehydration of methanoic acids. The question is methanoic acid, RO, concentrated sulfuric acid, carbon-2 oxide plus water. Chemical equation is HCOOH, solid, RO, concentrated sulfuric acid, CO, gas, plus H2O, liquid. Now B is dehydration of ethanedioic acid, which is also called oxalic acid. Now the equation there is ethanedioic acid, RO, concentrated sulfuric acid, gives you carbon-4 oxide plus carbon-2 oxide plus water. Chemical equation is H2C2O4, RO, concentrated sulfuric acid, CO2 gas plus CO gas plus H2O liquid. Now collection of carbon-2 oxides. Now when you are using methanoic acids, the gas is collected after preparation. The gas is collected by over water methods. Reason: carbon-2 oxide is lightly soluble in water. Now when you are doing dehydration of ethanedioic acids, because you are forming carbon-4 oxides, carbon-2 oxide and water, the mixture of gases is passed through concentrated sodium hydroxide or concentrated potassium hydroxide to absorb carbon-4 oxide, and then the gas is collected by over water method. Now if this gas is required dry, carbon-2 oxide is passed through concentrated sulfuric acid or anhydrous calcium chloride, then collected using a syringe. Below shows preparation of carbon-2 oxide by dehydration of methanoic acid. So the first diagram, this diagram here, is by dehydration of methanoic acid. Where you place here methanoic acid here, you place here concentrated sulfuric acid. Now once the gas is prepared here, you are told that do not collect the initial sample of gas because it is impure, that is, it is mixed with air originally in the flask. After the gas is prepared here, it is collected by over water method here. So this is water, this is a trough, and this is the gas here, carbon-2 oxide. Now when you prepare the gas by dehydration of ethanedioic acid or oxalic acid, the setup diagram is as follows. Now I said this is a dropping funnel here. When you're using a dropping funnel, it should not be dipped in the solution. Unlike when you are using a distal funnel, the funnel should be dipped in the solution here. So this one you place here ethanedioic acid, you place here concentrated sulfuric acid, which runs inside here. It forms two gases, carbon-4 oxide and carbon-2 oxide. The gases are passed through sodium hydroxide concentrated to remove carbon-4 oxide. Then the remaining carbon-2 oxide is collected by over water method here. So this carbon-2 oxide, this one is water here. Now the other method, number 2, is reduction of carbon-4 oxide using carbon. The word equation is carbon-4 oxides plus carbon, RO, carbon-2 oxides. Chemical equation is CO2 gas plus carbon solid gives you CO gas. To balance the equation, place 2 where there is carbon 2 oxide. Now, after preparation of the gas is passed through concentrated sodium hydroxide or potassium hydroxide to remove unreacted carbon 4 oxide. Then the gas is collected by over water methods, because you have said the carbon 2 oxide is lightly soluble in water. Now, other sources of carbon 2 oxide can be combustion of charcoal and fossil fuels, e.g. kerosene, diesel, petrol, coal in insufficient supply of air. The diagram below shows preparation of carbon 2 oxide by reduction of carbon 4 oxide using carbon. The air enters through this section here. Air enters through this part here. So the reactions in this will occur in 3 sections. You have region A, region B, region C. Now in region A, there is plenty supply of air entering the chicle, allowing complete combustion of carbon to form carbon. The equation is carbon plus oxygen arrow carbon 4 oxide. Chemical equation is C solid plus oxygen gas gives you CO2 gas. Region B, carbon 4 oxide produced from region A rises up the region B, where it is reduced by hot carbon to form carbon 2 oxide. Now equation is carbon 4 oxide plus carbon arrow carbon 2 oxide. Now chemical equation is CO2 gas plus carbon solid arrow carbon 2 oxide gas. Balance the equation, place 2 where there is carbon 2 oxide. Now in region C, in case there is plenty supply of air in this region, carbon 2 oxide from region B burns to form carbon 4 oxide gas. Equation is carbon 2 oxide plus oxygen arrow carbon 4 oxide. Chemical equation, carbon 2 oxide CO gas plus oxygen O2 arrow CO2 gas. Balance the equation, place 2 where there is carbon 2 oxide and 2 where there is carbon 4 oxide. Now in case of insufficient supply of air, some carbon 2 oxide produced in region B is released into the atmosphere. Now physical properties of carbon 2 oxide include: it is a colorless gas, it is an odorless gas, it is slightly less denser than air, as the density of carbon 2 oxide is 1.25 grams per centimeter cubed, while that of air is 1.2929 grams per centimeter cubed. 4. It is slightly soluble in water. Now chemical properties include: 1. Reaction with oxygen. Carbon 2 oxide burns in air with a blue flame to form carbon 4 oxide. Equation is carbon 2 oxide plus oxygen arrow carbon 4 oxide. Chemical equation: CO gas plus oxygen gas arrow CO2 gas. Balance the equation, place 2 where there is carbon 2 oxide and 2 where there is carbon 4 oxide. Now 2 is the reducing property of carbon 2 oxide. Now carbon 2 oxide is able to remove oxygen. Carbon 2 oxide is able to remove combined oxygen in metals, e.g. copper, zinc, lead and iron. So A, reaction between carbon 2 oxide and copper 2 oxide. Chemical equation is CO gas plus CuO, that's copper 2 oxide, arrow Cu copper plus CO2 gas. Now observation made when carbon 2 oxide passed over heated copper 2 oxide. During the experiment, you say black copper 2 oxide changes to brown. At the end of the experiment, we say black copper 2 oxide changed to brown or you can say a brown solid is formed. Reason is carbon dioxide reduces heated copper dioxide to brown copper while itself oxidized to carbon 4 oxide. B. Reaction with heated lead-2 oxide. Chemical equation is CO carbon dioxide plus lead-2 oxide solid arrow lead solid plus CO2 gas. Now, observation made when carbon dioxide is passed over heated lead-2 oxide during the experiment, we say yellow lead-2 oxide changes to gray. At the end of the experiment is yellow lead-2 oxide change to gray or a gray solid is formed. Reason, carbon dioxide reduces heated lead-2 oxide to gray metal. Carbon dioxide reduces heated lead-2 oxide to gray lead metal while itself oxidized to carbon 4 oxide. C. Reaction with heated zinc oxide. Chemical equation is CO carbon dioxide plus zinc oxide arrow zinc solid plus CO2 gas. Now, observation made when carbon dioxide is passed over heated zinc oxide is during the experiment white zinc oxide changes to yellow and then finally to gray. After the experiments, a gray solid is formed, or you can say white zinc oxide change to gray. Reason is carbon dioxide reduces heated zinc oxide to gray zinc metal while itself oxidized to carbon 4 oxide. D. Reaction with heated iron 3 oxide. Chemical equation is iron 3 oxide plus CO gas carbon 2 oxide arrow iron metal plus CO2 gas. To balance the equation, place 3 where there is carbon 2 oxide and then place 2 where there is iron. Observation made when carbon dioxide is passed over heated iron 3 oxide is during the experiment brown iron 3 oxide changes to gray. After the experiment, a gray solid is formed. Reason is carbon dioxide reduces brown iron 3 oxide to gray iron metal while itself oxidized to carbon 4 oxide. Now, uses of carbon 2 oxide include it is used as a reducing agent in the extraction of metals. And then 2, it is used as a source of fuel when mixed with hydrogen gas.